what we're doing right now is we're finishing the lab report. So let me show you how to write a sample calculation for a formula in your sample calculation data section. All right. So what each of us have just done is we've all gone through our data sections and we've numbered our figures in the data section that we're going to be referring to in our lab report, okay? Now, I want to point out a few things about mine that are different from yours, because these are the things I'm assessing for higher order thinking. I can't write it and share it with you because then you won't have to do the thinking, which is what I'm assessing. So as I go through, I'll point some things out that are missing. So these are my labeled drawings of slides. I am going to cite these in the conclusion of the lab report when I talk about stages of development that the failures didn't make it to. I'm also going to cite these three tables when I talk about stages of development that the removals made it to or didn't make it to. So the most efficient way to do this is filling out these removals and talking about when in development these buggers stopped. Okay, so when in development did this stop? Possibly fertilization. This might have, if you haven't jotted this in there yet, this is a good time to do that. I think this is pretty simple stuff, so we can go ahead and put this together. Potential failure before fertilization or just after? Or just after? Okay. What about this one? Maybe, yeah, or maybe made it to early organogenesis. Yeah, so this failure during gastrulation or very early organogenesis. I would say that this looks like, to me, this is mostly undifferentiated cells. So in other words, it could have failed during gastrulation and started making a body, but it had no body plan. Or at least it's not easy to discern different tissue types. Whereas here, definitely we can see different tissue types, right? This isn't a leg yet, but that's almost a wing. There's no beak here, but there is a mouth hole, right? Okay, so that's where you start, that's the stuff that you're going to be describing. And then you can cite these drawings as you describe it. I can cite table 3 if I'm talking about organogenesis, but this one here is most certainly a failure during organogenesis. Organogenesis. And then here you could even put days. Days post-fertilization. Okay, that's a guess. You're going to put a number in there. You're going to number days post-fertilization. And as long as it's consistent with our samples, which are overlapping in days, it's fine. It's correct, right? We got to understand that there is some variation in developmental timing. So anything probably less than 8 days and greater than 3 days is acceptable there. All right, this is another failure, but it's obviously older. I'm just pasting. Whoa, I just pasted. I thought I pasted. Failure during organogenesis. And this is a failure. We're going to call this, these are late failures. And organogenesis was nearly complete. Okay, and then I want to remind you what the example looks like. In the example, we talk about all of the things that formed correctly and events that led to that were noteworthy in detail, describing genes and tissues and stuff like we did for Quayle Johnson, okay? And then I cite some figures here. Okay, now, once you've got the removals table done, all right, that is what I'm talking about here in the conclusion rubric. Well, problems with the way the experiment was run, I've started to write about, which is us not tracking temperature and humidity, right? Proposing when during development something went wrong with a few chick removals. This is where you refer to the removals table. And you might have added a photograph of a different bird than me or whatever to that thing. This is where you talk about and support the reasons using correct biological vocabulary why specific birds, what specific birds didn't do, right? When in development did they fail? What genes didn't get activated, right? And I want to remind you, so this is the most difficult developmental and genetic part of the lab report, is number 5 in the conclusion, which we're already 2. Okay, we already went through and we used plentiful explicit data to evaluate whether the hypothesis was supported or refuted, restated the hypothesis. Why does it say each? Okay, and we restated the purpose. It's weird that I only gave us 10 points for this. It should be like 100 points. I don't know. Okay. Here are your choices, though. If you put a ton of detail in this description here about development and walk me through like what went well and what didn't go well, using your introduction as a source, right? For these ones, you want to talk about this one has a developmental failure posteriorly. And I believe this is the one where I was like, that's intestine. That's not just yolk. There's actually intestine outside the body in this one. So that's not supposed to happen. So intestine, not enclosed in posterior body cavity. That's problematic for this one. This one here is actually forming pretty normally, and it's hard to see, but the yolk hasn't gone in completely, but that's kind of okay. That's supposed to happen last. So that's not, this might just be weakness, overall weakness after, not being able to chip out. Cool. Yeah, which one was that? I think it was, did I take a picture? I feel like it's one of the ones I pulled out.
Most of them sugar had not.
Yeah, had made a little chip. Yeah. The pit. Yeah. Uh-huh. But we didn't define it, so. So I don't know why I'm putting this in here, just because I'm a nerd. Okay, so just start writing that stuff and don't let me, that's the next part of the conclusion. Oh yeah, and I'm making this video for seniors. So first, y'all, we restated the purpose. We changed it to past tense. I restated my hypothesis and I changed it to past tense. I reported the hatch rate, and then I reported data about from the figure that shows temperature and humidity that shows we didn't meet our conditions. Our conditions were if we keep the incubator within acceptable conditions, then we defined them. We should obtain a hatch rate of 75%. Now, I'm not sure we would consider our temperature range outside those conditions, but I would say our lack of data is very suspect. That's the kind of thing you can propose easy ways we could fix the experiment to. But now let me do this one thing here, sample calculations. So for a sample calculation, you simply go to your Google Sheet, you find a column. I'm just going to use this first column here. We have a percent mass loss of 2.06. We can all see that, right? For Eugene. I go back to my lab report, right? And this is percent mass loss sample. So I say equals 2.06%. Okay, and it looks like it was intake mass minus candling day mass divided by intake mass. So then I go over here and I make my formula, zoop. There's a minus, there's a zoop, there's a divided by, and there's a zoop, and there's a times 100%. Great. So now I go in there and I find those numbers. Mass first candling, 9.5, intake was 9.7. Those are my numbers. So 9.7 minus 9.5 divided by 9.7 times 100% equals 2.06. Woohoo. That's how you do a sample calculation. Oh, we never did percent air sac. We didn't do that in this lab. That is not applicable. We did not measure air sacs. Okay, do people know what to write? You're going to write about specific removals and failures. I can't also do it because then that would just be doing it for you. Yep, start working. Work in earnest. Hey, Ava.
Yeah.
I'm going to end the meeting to make the video, and then I'm going to come right back.
Okay. Cool.
Okay.